Today we're going to visit the home observatory of Kevin Quin. It's called the Hole in the Trees Skybox, and the reasons for that will become apparent pretty quickly. Kevin is an amazing imager. He's been imaging for at least 10 years and has become the organizer of Novak's imaging group, where he tries to help all of us learn how to get better, and I hope one day to be at least half as good as Kevin is now. He does, despite the limitations of imaging from what's probably a Bortle 8 sky, does amazing work. And he built this observatory to help him maximize the use of his limited sky. And we're going to go see how he did that today. I apologize in advance. We had a few technical glitches in the field, some problems with Kevin's microphone, and so I had to re-record this introduction here without Kevin, and I also, Kevin's microphone is coming through, Kevin's audio is coming through my microphone, and I'm going to try to do what I can to make that better in post-production. But if Kevin's audio is noisy or quiet, it's my fault, not Kevin's. We will do better next time. So without further ado, let's take a look at Kevin's observatory.
I probably should have swept it before,
That's okay.
before you guys came here.
We'll fire the maid.
I didn't think about that.
Oh, wow, nice.
You want to shoot while I'm rolling off?
Yeah,
Yeah.
go ahead.
Oh, get out of the way. Now, is that as far as it goes, or?
Well, it'll go about.
Well, what stops it?
Well, there's a stop at the far end of the framework, but
I got
what maximum is right there. That's it.
Nice.
But since this is my deep sky imaging rig, I don't usually need to push up that last few inches. This is going to see all the sky, even if the roof is only open to like here, because of the trees. That's why.
So
let me take this off so you can see the other scope that's set up here.
So this is your planetary scope, or
planetary
visual,
or visual. Yeah,
and
that's right.
and that's a C11.
Yeah, this is a CPC 1100, the old
Okay.
old style before the edge scopes came in with the better optics.
Okay. And this is not the Celestron wedge, is it?
No, this is a Milburn wedge. It's just giant slabs of aluminum. It weighs, I think, like 45 pounds, but it is just solid as a rock. It does not vibrate around the way the older wedges did.
Okay. And on your deep sky side, you've got another C11.
Right.
And a Paramount MX Plus.
That's right. That's what this is. Yeah.
And
so this is also the older C11. Both of them here are.
So you're doing something that most people would find pretty challenging, which is to do deep sky imaging with a C11. What got you down that path? Why not the larger, wider field, or the larger field scope, like a smaller refractor or something like that?
So I started out with Celestron SCTs back in, that was the first real telescope I got way back in 1985. I got a C8. So was familiar with SCTs when the motors on the C8 started to die. I had to decide what to do. At that time, I was mostly doing planetary imaging. I had started a little bit of deep sky, but wanted to continue using the same scope for both planetary and deep sky imaging. And so the moving up to a C11 seemed like the obvious choice. Also, at that time, I had finished the first Skybox, the doghouse size one, and I had intentionally sized it. I had the C8 at that point, but I had intentionally sized the doghouse to fit a C11 into it if I eventually decided to go that path. And pretty much within about 6 months of the time I built the doghouse, the old C8 die. So it was a good thing that I had planned it to be big enough to squeeze a C11 in there, because that's what I did.
So how many people did it take to build this? Did you build it yourself, or did you have someone come in and build it?
I built most of this myself. When it came time to pour the concrete to put the piers in the ground, my son and a couple of other teenagers from the neighborhood helped me mix up the concrete and pour that. We had a fun concrete pouring day with pizza and all that sort of stuff. Then a month or so after that, I was just about ready to put the roof on, and spontaneously, 3 people in our astronomy club pretty much just volunteered all at the same time, said to me, "Hey, if you ever need help finishing off that observatory, let me know." And I thought, yeah, I could use some help, because it's time to lift the roof rollers into place, which is I've been told people have done it with one person. I cannot imagine how.
I can't either. That roof looks pretty heavy.
The roof itself is heavy, but the real challenge was there are the runners that this fits into. With the rollers on them are 4x4s, and it's all pressure treated 4x4s. And a pressure treated 4x4 that's 12 feet long weighs well over 100 pounds. At least if you get it from Home Depot, like I did. And so if you have 2 of those, you got to figure out, how am I going to hold, say, 250 pounds of weight 10 feet apart and hammer them together at the same time. And that's why I had not only the 3 guys from the astronomy club that had offered to help out, but I had the 3 teenagers all on that day again. And then after that, the guys from the astronomy club helped me finish a couple of things on the roof, get the metal onto the roof. But I mean, yeah, for the most part, I would say doing the foundation, framing it out, doing the basics, I had gotten that started. But it was great to have people to help out with the roof. That really made a difference.
So did you design this yourself, or did you get plans from somewhere?
This is mostly from it's designed by a company called Skyshed up in Canada.
Okay.
I did a few tweaks on their design, but there is one other company that I know of anyway that does plans that you can purchase, called Backyard Observatories. They're both pretty similar. I think the two key differences that I saw were, the Skyshed plan assumes that you use what I guess shed builders would call skids rather than a concrete foundation. So it just sits on top of the dirt, right? You put some 4x4s down there and you build your observatory on top of it. I decided I had not 100% positive experience building a skid shed in my yard before. And decided I was going to put them in concrete. So I have 4x4s sunk into concrete supporting the observatory. Otherwise, this is pretty much the Skyshed design.
Okay.
The key about Skyshed is you use these garage door rollers. The alternative approach that Backyard Observatories takes is you put an angle iron on top of the 4x4 supports here, and then a steel wheel will be what your roof rolls on. So steel wheels on top of the angle iron, as opposed to garage door runners that go inside a garage door track.
Okay. Now, how deep did you have to dig for the concrete for the piers and for the foundation?
The piers are about 4 feet down.
And how wide?
18 inches.
So that was quite a bit of digging.
That was a lot of dirt.
Especially if your soil is as much clay as ours is.
It is. I was really lucky in that I really did not find any rocks. Mm-hmm. We have occasional big chunks of quartz here too. And I was very fortunate. I was digging this out with a manual post hole digger, just bashing it into the ground for about 8 hours. And I was very fortunate that I did not find any large rocks that would have required smashing out with a chisel.
How long did it take to dig those 2 holes?
It was pretty much about a full day of work.
Okay.
I got a lot of exercise that day. And, I mean, the key problem really was finding out where do I put all this dirt. But it was a good amount of exercise, but it worked out.
And how did you get to go for the foundation
The
footers?
foundation, there's 6 4x4s in the ground, and I think they're only about 3 feet down. That was a lot easier because just like you were digging out a fence post, just enough to throw maybe 1, maybe 2 sacks of concrete into it. Whereas underneath each of these piers is almost 1,000 pounds of concrete. That was a lot harder.
So obviously, when you opened the roof, you used ropes and a pulley system.
Yeah. The high-tech approach.
Yeah, which, I mean, it works fine, but have you given any thoughts to automation?
I have. I've occasionally pondered the idea of putting a roof motor in here, because then the observatory could close itself up automatically. And in theory, I guess you could program it so it could open itself up automatically. The question for me has always been, how much time do I want to spend building that, climbing the learning curve to figure out how to use it, integrating it with my observatory software, and getting it all up and running, as opposed to solving the innumerable other challenges that I face when I'm running an observatory. And it's so far stayed fairly far down the list, but maybe in theory someday in the future.
So for your equipment here, obviously you've got the 11-inch SCT. What else do you have going on here?
So on the back end here, I actually have this set up right now for some troubleshooting.
Okay.
So this is a ZWO or a ZWO web camera. You'd normally use this for planetary imaging. Normally I would have my deep sky camera back here, which is a Starlight Express H694, which is maybe about that big. I put the video camera on here a few days ago to do some troubleshooting, trying to figure out some vibration that I'm seeing. So you see, that's yet another reason that the roof motor is further in the background here. This is a 7-position 1.25" filter wheel. Then on the other side here, this is a rotator that will automatically move rotate the camera orientation during the night. And in between them is an Orion pin off-axis guider. And then at the back end of the telescope is a 0.63 reducer from Celestron.
Okay. So with your normal camera and even with a reducer, you must have a pretty small field of view.
Yeah, it's about 28 arc minutes by 22 arc minutes.
So how does that influence what you decide to image?
So the combination of small field of view and light polluted skies has pushed me to some extent through to imaging planetary nebulae. They're always a pretty good target to image. I have recently started to get into trying to do some mosaics to be able to get a little bit more wider areas of emission nebulae or diffuse nebulae. And have started to do a little bit of that. But even with the 28 arc minute field of view, there are a fair number of things that you can get. I mean, you're not going to get the California nebula, you're not going to get the North American nebula, unless you really wanted to suffer through a lot of mosaicing. But there are still a fair amount of big things that you can get. Globular clusters, big galaxies generally fit in. Some galaxies, so M31 won't fit in, M33 won't fit in, but there are actually a few other galaxies that are just slightly too big, M101, M81, a few things like that. But generally, any bright galaxies, any planetary nebulae, some smaller galaxy clusters, globular clusters, they all work out pretty well as targets.
So how long do you typically spend per target?
On a diffuse nebula where I'm shooting narrowband, I usually try and shoot 6 hours per channel, which winds up with about 18 hours. But I can go as high as, I think the longest target I've ever shot, and this was kind of by accident, or kind of by laziness too, was M76, the little dumbbell nebula in Perseus, I think. And I put 59 hours on that.
Wow.
That was sort of along the idea of, well, back before I really had planned out a list of targets and had a list always ready so I never had to ask, what should I shoot tonight? Well, for a while, the question, what should I shoot tonight, was, yeah, let's just put some more time in on M76.
Okay.
And then when I finally looked at it, I realized, yeah, I have 59 hours on this target. But normally, maybe 18, 20 hours on a diffuse nebula, on galaxies. I've gotten a lot more aggressive on galaxies lately, to try and put a lot more time into them. So I'd say I started out doing maybe 5-6 hours at most on a galaxy. But now, particularly on like galaxy clusters, I'll try and put, as many hours as I put in on diffuse nebulae. So, 18, 20 hours.
So what was your most challenging target?
They're all challenging targets. That's each time I think, oh, this one will be easy, or this one will not be as hard as the last one. Somehow it winds up pretty much being as hard as the last one.
It's not just me. Good.
No, it's not. I think it's a combination of like maybe I pick a more challenging target, but it's also on the processing side. That I think, oh well, all those processing tricks that I learned last time, I can try those again, plus some new ones, and so they're pretty much always challenging in one way or the other.
Okay, so obviously you've got this nice observatory here. What is this, 10 by 12?
This is 10 by 12.
And you've got 2 telescopes in here, but the one thing I don't see is any sort of chair or desk. So I'm guessing oh, it's behind me.
So there is in fact a chair out here.
There is a chair.
This is only used for a few minutes each night because I can control the observatory from inside my house through Wi-Fi. So I have the laptop out here runs the observatory, and then when I'm inside my nice, warm, and mosquito-free house, I can control it from the desktop inside there.
Okay.
And that's all through TeamViewer.
So you don't spend very much time out here. Just roll the roof back off, take the lens caps off, and you're ready to go.
That's pretty much it. Yeah.
What's been, I guess, in terms of maintenance? Has there been any challenges that you weren't expecting?
On the observatory, no, not really. A few little tweaks that I had to do to it to make sure everything was working exactly as it should. Prevent boards from rubbing against each other, prevent beams from twisting, a few things like that. But for the most part, once I got the observatory done, I haven't really had to do much to it over the last couple of years. It's been pretty resilient on its own.
So you've got a vent there, but you don't run any kind of fan or anything normally, do you?
No. There's a vent at the gable peak on each side of the roof. But truthfully, the observatory is drafty enough that I don't know that it's really all that important. The vents, I'm sure, let out some heat on summer days. But I've never thought about putting a fan in here or anything like that.
Never been so warm that you were worried about it being too hot.
No. But, it will get plenty hot out here. There's a couple tricks to this. First, the roof is white, but inside the roof, we can show you that. Either I can bring it back, or we can go outside underneath it and take a look. On the underside of the metal roof, there's not plywood up there. But what you see up there is this sort of aluminum, it's basically aluminized bubble wrap that you can get from the hardware stores. This is called Reflectix. And the idea is not only will that keep out some of the heat on a summer day, but it will also prevent moisture from condensing on the underside of the metal roof. Never had a problem with condensation inside the observatory, so that's worked out pretty well. And like I said, it's pretty much drafty enough that heat buildup isn't really a problem. Although, if I can, I'll come out here, maybe an hour before I'm planning to image and roll the roof back to let the scopes adapt a little bit from the heat of the day.
Mm-hmm. And if you don't mind my asking, about how much did you spend to build the observatory itself?
I would guess all total, this is the wood, metal roofing, concrete, everything like that. Probably about $2,000.
Okay.
That'd be my guess. Maybe a little bit over that, but pretty close.
All right. So, is there any question that I should have asked you that I haven't?
Sure. What was my biggest mistake?
Yeah.
This is I think something that everyone should ask when they're building an observatory, or who has built an observatory. What was your biggest mistake? And I'd say I made two of them, but I guess we'll do them in order of decreasing magnitude. Mistake number one, this will actually be more obvious if I close the roof.
Sure.
And then it'll be perfectly obvious what mistake number one really was.
Now you say obvious, but
You see it?
people are not much more mechanically inclined than I am.
So if you come a little bit closer and you think, that doesn't really look like a shed, and the reason is because there's this overhang here, which there isn't really a whole lot of explanation for, except that once I finished framing out the roof, I realized it was 3 inches longer than the observatory itself. And what had happened here was I had misread the instructions on the sky shed plan, and I had made the runners that the wheels, the garage door track wheels, sit on 3 inches longer than they should have been. And I was looking at that the next day and trying to figure out now what, and was preparing to block the roof and shorten the beams on the roof, the rafters, and cut it back 3 inches when, fortunately, one of the guys who had volunteered to help me out said to me, there really is an easier solution that will avoid that, which is what I've done here. Let's see if I can pull this back a little bit. So he pointed out that all I really needed to do was to put a backing board up here and then use a garage door bottom, this rubber bumper down here. And with that seals up the opening, so I don't have an open overhang that's basically begging bats to come and roost in it. And that has sealed up everything. So that saved me from having to cut my rafters back and redo my roof and spending a couple of days doing that.
And your second mistake?
The second mistake was a more could have been a worse mistake. So when I built the observatory, I actually built the foundation and started framing it out while these piers, the steel piers, they were also from Skyshed. They were being fabricated up in Canada, so I didn't actually have them. So I had dug out the holes for the piers, but I had not poured the concrete yet. So I was waiting for the piers to arrive before making the pattern for the bolts. And I had dug out the holes and had been building the observatory. And the summer had been very dry, but after a while, looking at the forecast, there was going to be about a week worth of rain. And I said it was one thing to leave those holes underneath the observatory all opened up while it was dry. But if rain came down, the holes were going to start to fill with mud, and life would be a lot harder. So I finally said, I got to pour the concrete. So, and the folks up at SkyShed had been encouraging me, you can do this. You can make the bolt pattern and you can pour the concrete, everything will be fine. So I went ahead, I poured the concrete, I made the bolt pattern, set the lag bolts into the pier bases, and let it harden. That was our concrete pouring day. And about a week later or so, the piers arrived. Came out to put the pier on top of the foundation with the bolts, and realized that the bolts were about 1/4 of an inch off.
Oh no.
And when you're dealing with a pier that is basically 1/4 inch slabs of steel welded together, there isn't really an easy way to make bolts go through 1/4 of an inch of steel. It was not, I have no idea how I did that. I swear I measured that pattern about 8 different times. And each time it was just fine, and it was right, and it was good. And then apparently on the 9th time, when I actually made it, I changed something. So the bolts, and of course I used the same pattern for both piers. I used that as a template. And so both of the piers were wrong. Not a tragedy though. I took the piers off to a machine shop just a little ways down the road, and they widened out the holes a little bit, and so it works out fine. But that was the first of the big mistakes. That was actually before the roof. So unknown to me, I had not yet made my biggest mistake in building my observatory. But both of them have worked out fine. So.
So how did you get electricity out here?
This is the part that should probably be edited out of the video.
All right, maybe we shouldn't ask that question then.
I run an extension cord from the house.
Okay.
Most people would go out, a lot of people would go out and they would trench it out and put in electric underground and tie it into their house. And yeah, you can do all that. And the one thing you can't do is bury an extension cord, but there isn't really a reason that you can't leave an outdoor extension cord outdoors. And I check it on a regular basis, and I will admit I once did hit it when I was building that fence that you see right there, and couldn't figure out why the breaker had tripped inside. Until I went and followed the extension cord out and realized, oh yeah, I built a fence here. But the extension cord just runs out. And as long as it stays above ground, you don't do anything dumb like bury it or build a fence on top of it, it's been fine. So it runs along the base of the house, runs along the base of the fence. It's not anywhere that a lawnmower could hit it. It's not any place that a snowblower or a shovel is gonna dig into it, at least not now that fence is permanently built. And then it just comes up through the floor of the observatory here. And then I just run the extenders off of it. If the observatory used more power, I would be concerned about that. But the only power that's out running here is the power that runs the camera, power that runs the dew heater, and power that runs the mount. And I can't imagine that's ever, on an extended basis, I can't imagine that's ever more than 1 amp, maybe?
Yeah, I know.
Probably less than that.
I know at 12 volts, using a smaller dew heater, because I have a smaller telescope, I'm using, worst case, about 3 amps at 12 volts.
Yeah.
So at AC currents, you can't be drawing much at all.
Yeah, I mean, in theory, that dew heater can draw 5 amps, but I can't imagine any occasion that it would actually be doing that.
Right, but that's 5 amps at 12 volts.
At 12 volts,
So
yeah.
when you scale that up to 110, it's
Yeah.
not that much current.
Yeah, so that's why I've never been particularly worried about it. I mean, talk to the other much smarter people on the observatories forum at Cloudy Nights while I was building this thing, and everybody said, whatever you do, never bury an extension cord. But as far as, as long as it's heavy enough gauge, then it's been fine. And honestly, I think, I replaced it about a year and a half ago after I hit the first one digging the fence out. But that one had been out here for almost 10 years. And got a little bit heavier gauge one this time around, but it's, as long as you got a heavy duty cord that's intended for outdoors, it saves you the trouble of having to dig out underground conduit and tie it into your house.
Have you ever had any trouble with the critters or rain or moisture getting in?
In Skybox 1, the doghouse, the chipmunks would occasionally try and nest inside of it. I eventually put mothballs inside it. And that mostly did the trick. They found that there were better places to go, I think. In the bigger one, strangely, no. I have never had any bugs inside here. Well, sure, I have spiders every once in a while, but there'll be webs out here now and then. But maybe it's just because there's more space in here. They like a more confined area. Never had a bat, although I've heard people who have discovered bats in their observatory every now and then. As far as rain, no, never had any problems with rain, and obviously that's always the key concern. So certainly the first few times we had real rainstorms after I built the observatory, I was out here underneath it, checking all the roof panels and making sure no drips had come down. Check the floor the next morning to make sure that there were no spots on the floor. But yeah, it's been fine. I think the combination of the pretty tightly tied metal roof panels and the reflectix underneath them has prevented any problems from that.
Fantastic. Well, Kevin, thank you so much for allowing us to come in and see your observatory.
Sure.
I know I'm envious. I have my sky is not quite as many trees as yours, so I figure if you can do this eventually, I should be able to.
Yeah, it can be done. And the real disadvantage of this place, in addition to the trees, is the light pollution.
Mm-hmm.
But the counter to light pollution, in addition to narrowband filters, is time. And you'll be able to get time on a target when you're permanently set up in ways that you couldn't if you had to drive out to the back of beyond to image.
That's true. I imagine if you've got a night where it's like, oh, I might get 2 or 3 hours in, well, that's worthwhile because that's all you can ever get on a target anyway.
That's right.
And for me, if I can only get 2 or 3 hours in, it's like, that's a lot of work to set up to just get 2 or 3 hours.
Well, I can also come out here on nights that might be kind of marginal,
mm-hmm.
that I might think, well, I'm not sure it's going to clear up at all, and I don't have to worry about, the investment of getting everything together and getting it all set up and transporting it and everything like that because it's already here.
Yeah, and I imagine with your walls being relatively high compared to the where the telescopes are, your wind isn't quite as much of an issue.
Yeah, the other thing that's helping with wind is the trees.
That's true.
Most of my trees are off to the northwest, and the prevailing wind around here is from the northwest. So the combination of the trees and the wall actually do help a little bit with that.
Yeah, I was out. Well, I wasn't out, but the telescope was out imaging last month, and it got windy in the middle of the night, and I came down and watched a guide trace that looked like a seismograph.
Yeah.
And suffice to say, I didn't get much that night.
Yeah, that happens.
But when you got a setup like this, then it's easier to go out and take that chance because you're not spending as much time with setup and teardown.
Yeah, that's absolutely it. There is no setup, there's no teardown, and so if the clouds roll in, I just come out and I roll the roof closed.
Yeah.
There's no labor associated with it anymore once the observatory is built.
So from I guess design stage to first light, how long did it take you to get to this point?
Well, the design stage was a long period of agonizing.
Mm-hmm.
I was probably designing it from the time I built the first observatory back in 2009. But once it became clear I was really going to need to build a new observatory, I had pretty much already known about Skyshed and backyard observatories and the fact that they had plans available. So spent about a month maybe thinking it through and planning it out. And then construction was probably, I mean, to finish everything, to get all the last touches on, I probably devoted most of the summer of that year to putting this together. So maybe 5 months. I mean, real construction probably May to August, maybe September. But it certainly could have been done faster. Somebody more skilled in shed building probably would have saved a lot of labor and been able to do it faster than I did as well. But probably 4 or 5 months.
Okay. Well, thanks.
Sure.
Really appreciate it.
Sure. Happy to help.